Systems of equations can be solved in many different ways. In this video, I'm going to show you how you can solve a system of linear equations by graphing. Just a little background with solving systems of equations. There are three possible answers you could get for a system of equations. You could get one possible solution, which just means the two linear lines cross exactly once. You could have zero solu- solutions if both linear lines do not cross, which means they're going to be parallel. Or you could have many or infinitely many solutions, which just means the two equations are equivalent. That means they are the same equation. So that means they overlap everywhere. So when you graph them, they look like just one line, but it's one line on top of the other line. So in this example, 2x minus y equals -3 and 2x plus y equals -1. We want to determine, is there one solution, zero solutions, or many solutions? If there is one solution, we are going to find the exact point in which the two lines meet. So we're going to get an x and a y coordinate for that. Now, when you're graphing linear equations, it's probably going to be best to put it into slope-intercept form. You could graph them if it's in standard form, and then you use the intercepts. But for the examples that I have here, it'd be easier just to put it into slope-intercept form. That means we want to get our y by itself. So in this top one right here, I'm going to get the y to the other side so I can have a positive y, and then I'm going to get this -3 to the other side. So I'm really going to be adding y and adding 3 to both sides. So when I do that, this 3 cancels off, this y cancels off, and I'm left with an equation of y equals 2x plus 3. Now this one I'm going to graph first. So we always plot our y-intercept. My y-intercept is at 3, so I'm going to put a point at 3 on the y-axis. And I just need a minimum of 2 points to draw a line. So I'm going to use my slope. My slope is +2. That means if I go up to 1, 2, I have to go to the right 1. Or if I go down to 1, 2, to the left 1, I just need to make sure that my line goes up from left to right. But if I want to make my line as accurate as possible, if I don't have a ruler, I'm just going to put more points down. So up to over 1, up to over 1, up to over 1, or if I go down to over 1 this way, that's pretty much a decent amount of points there. So then I can just draw my line through here. So that is one line. The other line, I'm going to change this to y equals mx plus b, but here I'm just going to subtract 2x because my y is already positive. So subtract 2x on both sides, and I have an equation of y equals a -2x minus 1. That means I put a point at -1 on the x-axis, or the y-axis, I mean. And this one has a slope of -2. That means from left to right, my line is going down from left to right. So I'm going to go down to the right 1. Or I could go up to the left 1. If I go up to the left 1 again, you can see my points there that make the lines. And then I can just draw my line through here. And typically I go, like once I have the first line, the second line, I don't put as many points because I see where the other line is going to be. I just put another point so it goes through the other line. So it's easier for me to see where the two lines meet. And you can see that the two lines meet right here. And my ordered pair would be x is -1 and y is 1. So you can either write it as an ordered pair, or you could just say when x equals -1 and y equals a +1. So that is an example where we have one exact solution and we are given what the solution is, -1, 1. Another example. Here we have another equation, 2x plus y equals 4, and y equals -2x minus 2. So for this one, the top one, I'm going to subtract 2x on both sides since my y is already positive and it's by itself. So I'm going to have y equals, this would be a -2x plus 4. And then I'm going to graph that one. So I put a point at +4 on the y-axis. And then I have a negative slope. Now, if you struggle with trying to determine what the slope should look like, you can use the Mr. Slope guy. So when the line is going up from left to right, it's positive. When it's going down from left to right, it's negative. If you have a vertical line, the slope is undefined. And if it's a horizontal line, the slope is 0. So here we have a negative slope. So that means it's got to go down from left to right. So if I go down to the right one, down to the right one, down to the right one, or I can go up to the left one, up to the left one, up to the left one. You can see I have plenty of points now that I can draw my line. And then I'm going to take my second equation, which is y equals -2x minus 2. I'm going to put a point at -2 on the y-axis, because that's my y-intercept. This one also has a -2 as a slope. So if I go down to the right one, 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 or I can go up to the left one, up to the left one, and just keep going up like that. We can see that if I draw my line now, the lines never meet because these are two parallel lines. And one way to determine, besides without the graph, that they are parallel lines is if you look at the two slopes, the slopes are identical. And if the slopes are identical, they are perpendicular, or no, they are parallel. That means you have 0 solutions, which means they never ever cross. And our final example, here we're going to graph these two equations and determine if it's 1, 0, or many solutions. So I'm going to take this top one here. Here, I got to get y by itself, so I'm going to subtract x on both sides. So right now I have 2y equals a -x plus 4. And to get y by itself, I'm going to divide by 2. And I have an equation of y equals a -1/2 x plus 2. Now, -x divided by 2 is the same thing as saying -1/2 x. Because remember, there is a 1 in front of this x here. So now to graph this one, I put a point at 2 on the y-axis. And this has a negative slope, so I'm going to go down 1 to the right 2. Down 1 to the right 2. Or I can go up 1 to the left 2. Up 1 to the left 2. And that should be plenty of points there, so then I can just draw my line here. And then our other one, this is already in slope-intercept form, so I put a point at +2. And then it's got a -1/2 slope. Now you can see that these two equations are identical, which means the lines are going to be the same. But just to prove it, I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, or I can go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, and then draw my line. The lines are right on top of each other, which means I can put any number in for x and y and they will still be equal. So this would be infinitely many solutions. So that is a quick review of how to solve a system of equations by graphing.